Alright, we have two special AP problems that we have to take a look at here. These were very unique problems that showed up in some of the AP practice books that we want to look at. These are very rare problems, but if you do encounter one of them, we want to make sure that you have actually seen something like it. Let's look at the first one. It says a city is built around a circular lake that has a radius of 1 mile. So I have a circle here for the lake, and what I'm going to do is make that 1 mile. The population density of the city is F of R, people per square mile, where R is the distance from the center of the lake in miles. Okay, which of the following expressions gives the number of people who lived within 1 mile of the lake? Well, what we have is a city that is being built up around the lake all the way around. And every time you go out a little bit, all right, there's more people that live around that perimeter of the lake. Well, what we're actually looking at is an infinite number of circumferences around the lake, and we know circumference is 2 pi r. Well, so if we take that circumference and multiply it by F of r, the number of people who live per square mile, we get a number of people. Okay, but we have an infinite number here, so we're going to take an integral. And we've got to figure out where the integral is going from. Well, the lake is from 0 to 1, and we're looking for the number of people who live within 1 mile of the lake. So we're actually looking from 1 to 1 plus 1, which is 2. And we are going to integrate in terms of r. And so what we get here is the integral of 1 to 2. We can take out 2 pi since that's just a constant. R times F of r dr. Now one thing you have to be careful of is the units. R we know is in miles. F of r they tell us is in people per square miles. And then dr, well that's the difference in r, that's also in miles. So you see that miles times miles is miles squared, that cancels out with those. And we're left with people, which is what we're actually looking for. And if we look at our answer choices, we got 2 pi, integral of 1 to 2, r of f of r dr, which is answer choice D. All right, very unique problem. Well, the second problem that is kind of similar to it is the one right below it. Now you have to draw this picture. This picture was not photocopied. So you want to go ahead and draw this. It is a city located beside a river. So here's your river. And its rectangular boundary as shown in the figure. Okay, they tell us that this is 7 miles in length and that this is 4. So these are all given within the figure that isn't photocopied. It says the population density of the city at any point along a strip x miles from the river's edge is f of x persons per square mile. Which of the following expressions gives the population of the city? Well, same kind of thing, but instead of circumferences, we're looking at strips that are measured x miles from the river's edge. Well, if these are all x miles, this would be the difference in x. And so we're looking at a whole bunch of little rectangles. And we know that the area of a rectangle is going to be length times width. Well, the 7 is constant. So this is 7 times dx. And if this is our area of the rectangle, we want to know how many people live in that area. So we're going to multiply that by f of x. Now, again, we got infinite number of rectangles. So we're going to integrate. And what's going to be shaded? If we were to shade this whole thing it's going from 0 to 4. And again, we can go ahead and take out the 7. We got f of x dx. If we look at our answer choices there, our answer choice is going to be B. Okay? And again, we can also check our units of measure. We know the 7 is in miles. F of x is persons per square mile. And dx would also be in miles. And again, miles squared, they cancel, and we have persons, which is what we're looking for. Sorry, I didn't move that one up fast enough. All right, so these are two unique problems that deal with population density. And again, you're taking the area, or in the one ahead of it was the circumference, multiplying it by the density, and then you're taking infinite number of them. And whenever you take an infinite number of something, we are integrating. All right, and then you're integrating, in this case, from 0 to 4. The one before was 1 to 2. Okay, so unique problems could show up on the AP exam.